So we're heading to Morocco, a place that's already one of the most water-stressed regions on the planet. A huge crisis is unfolding there, but it's not the one you might think. It's not just about the rivers you can see shrinking. Nope, the biggest danger is totally invisible, hidden deep, deep underground. For years, we could only guess how bad it was. But now we can see the truth, all the way from space.
Seriously, just think about that for a second. How on earth do you do that? How do you measure something you can't even see, something that's buried underground across a whole country? It sounds completely impossible, right? Well, the answer is pretty mind-bending. It involves a couple of satellites and some seriously cool physics.
All right, let's get into it. To crack this mystery, we've got to look up. Way, way up. We're talking about a mission that literally weighs water from orbit.
So meet GRACE. That stands for Gravity Recovery and Climate Experiment. Don't worry, you don't have to remember that. Just remember this. GRACE is basically a giant, super sensitive scale in the sky. And this is the key part. It doesn't take pictures. Instead, it measures the weight of water by sensing these teensy tiny changes in Earth's gravity. So how in the world does this work? It's brilliant, actually. You've got these two satellites flying one right after the other. Now imagine the first one flies over an area with a lot of groundwater. That water has mass, right? So it has a bit more gravity. That extra gravity gives the satellite a tiny little tug, making it speed up just a hair. The distance between the two satellites gets bigger. Then, when the second satellite flies over that same spot, it gets the same tug and catches up. Scientists measure these tiny, tiny changes in distance. We're talking shifts smaller than the width of a human hair. And from that, they can create a map of where water is disappearing on the ground. It's just incredible.
Okay, so now we have this amazing tool, and with this scale in the sky, scientists aimed it right at Morocco, a known hotspot for water scarcity, to finally see what was happening to its most precious hidden resource.
And you really need to understand the background here because it's pretty stark. This isn't some new problem. Morocco's been in a tough spot with water for a long, long time. Get this, back in 1960, the amount of available water per person was over 2,500 cubic meters. By 2020, it had crashed to just 620. That's a drop of almost 75%. So you can see why that underground water is so unbelievably important.
Yeah, this quote from the study nails it perfectly. Think of that groundwater like a national savings account. It's a strategic reserve. When the rains don't come and the rivers dry up, this is the emergency fund that keeps everything running. The farms, the cities, everything. But what happens when you keep taking money out of your savings account month after month, year after year, without ever putting anything back in?
Right. So what did that giant space scale see when it looked at Morocco's water savings account? Well, the results were not good. In fact, they were pretty alarming.
What GRACE found wasn't just a simple decline. It was a loss that was steady, it was widespread across the most important regions, and this is the really scary part, it was speeding up. The problem was getting worse, faster. Let's look at the actual numbers.
Okay, so in one of the most critical farming regions, the Haus Majete aquifer, the data showed a loss of about 0.37 centimeters per month. Now that might not sound like a lot, but imagine a layer of water that thick being scraped off the entire region every single month for 7 years straight.
And this wasn't just a one-off thing. Nope. Look at the nearby Bahira aquifer. It was basically the same story, a loss of 0.36 centimeters a month. This was a full-blown regional crisis.
This timeline really shows you how things are speeding up. Back in the early 2000s, the loss was about 1/4 of a centimeter a month. Then in the next chunk of years, it ticked up to 0.30. And then from 2015 on, it jumped again to 0.37. You can see it clear as day. The withdrawals from that water savings account are getting bigger and faster every year.
So, okay, we've seen the what? This huge, accelerating drain of underground water. So the next logical question is, why? Why is this happening? Well, the study points to two major culprits working together.
It really is a perfect storm. First, you've got nature. There have been these relentless, severe droughts, especially since 2015. That means there's just not enough rain to refill the aquifers. So, to go back to our analogy, the deposits into the savings account have basically stopped. At the same time, on the human side, there's been a massive increase in demand, mostly from farming.
And agriculture's thirst is just massive. We're talking over 85% of all water used in Morocco. Now, the country had this big push called the Morocco Green Plan to grow its farming sector. And on paper, that's a great goal. But here's the catch. When you're in a drought and the rivers and reservoirs are low, where do farmers turn? They have to drill wells and start pumping that groundwater. It creates this dangerous, vicious cycle, putting more and more pressure on that hidden savings account we keep talking about.
And if you want a picture of what that pressure looks like, well, just look at this. This is just one area. In 2015, there were 46 of these small irrigation reservoirs filled by pumping groundwater. By 2023, almost 900. That is not a typo. From 46 to almost 900 in just 8 years. It's an absolute explosion in demand, and all of that water is being pulled from that same shrinking, hidden supply.
Okay, so let's zoom out for the big picture here. What does all of this really mean? This isn't just about Morocco. What is this incredible view from space telling us about the planet?
Because really what the GRACE mission gave us is a new kind of superpower. I mean it. For the very first time, we can actually see the health of our planet's hidden resources in near real time. It's that old saying, right? You can't manage what you can't measure. Well, now we can measure it, even when it's very deep underground.
And that's really the bottom line of this whole study. This tech isn't just some cool science project, it's an absolutely essential tool. It gives the people in charge, the policymakers, the farmers, the actual data they need to see the consequences of their choices, and hopefully to start making better ones for a sustainable future.
So, that scale in the sky has done its job. It's shown us the honest, unblinking truth about our most vital hidden resources. The warning couldn't be clearer. So the question, at least for all of us, is, now that we can finally see the problem, what are we going to do about it?